I'm Jochen Lamote. I'm the head of the VIB Flow Core in Leuven. So VIB is an academic institute, and we focus here on two centers, the Center for Cancer Biology and the Center for Brain and Disease Research. Two very different centers. In the Center for Oncology, we focus more on immunophenotyping and characterizing the cancer cells with high parameter panels. On the other hand, in neuroscience, we're more focusing on isolating specific cells of the brain. VIB always wants to go the extra mile. We want to test new technologies, we want to go for implementation of new techniques. For this we need specific dyes that are exclusively excited by the blue laser, so this is why we're very interested in testing more RealBlue dyes. These dyes are very specific, and the advantage of this is that when you look at subtle changes, when you need a high resolution to see the subtle changes, that we can use now these dyes instead of dyes that are having some spillover in other channels, which always leads to compensation issues, which will decrease the resolution. So for very sensitive assays, we prefer to use these dyes. For example, the RealBlue dyes are exclusively excited by the blue laser. It was important for us to assess that you don't have crossover in the yellow-green laser, while, for example, PE size 7 will be excited by both. The more distinct fluorophores are and exclusive the fluorophores are, the better for us. Also because in academia our research goes very fast. We have a huge turnover, experiments change all the time. This is not like in a clinical company where a panel is designed once and optimized and is being used then for the next 3, 4, 5, 6 months or years even. The real blue dyes and the real yellow dyes have less issues with the spillover, so it's easier to just quickly switch markers without affecting the other colors in the panel. We recently discovered that you can use RealBlue 780 as an additional dye in your panels, so you don't have to switch markers anymore, in a way that we have panels which already have PE size 7, but RealBlue 780 is not cross-excited by the yellow-green laser. This is an advantage for us because we can just add this marker now to our panels and we can distinguish between RealBlue 780 and PE size 7 without any issues. We're really going to push our scientists as well to use these dyes who have less cross-laser excitation, because it makes the panel design way easier, especially between the blue laser and the yellow-green laser. There's a lot of cross-laser excitation with the currently available dyes. This will go away now if people really use the real blue dyes and the real yellow dyes instead of the typical PE tandem dyes that are existing. Especially now with the cell UV technology as well, it will open a whole lot of possibilities again to do new unprecedented experiments. We can address now new biological questions with these technologies. So innovative technologies are super important to drive our science.